So this is our third day of graphing quadratic equations. We've done standard form, we've done vertex form, we've done vertex form, we've done intercept form, now we're doing standard form. Standard form this is in your course pack. In your course pack on page 506. Page 506 are these notes. Pause, get that out. Standard form. Standard form is y is equal to a x squared plus bx plus c, where a, b, and c are some constant, some coefficients, some numbers. An example is this one here, y equals 2x squared minus 8x plus 6. The nice thing about standard form is I can do some things with it, and I can do that by pulling off my a, my b, and my c. My c isn't c, but my c is 6. The coordinates, the x coordinate of the vertex, also the the x coordinate of the vertex is x equals negative b divided by 2a. This is also the line of symmetry. So this is the equation I need to memorize. This formula, x is equal to negative b over 2a. I need to know that. I need to be able to use that at any time if necessary. So how does this work? Well, to find the y coordinate, well, we have to find the x coordinate. So I'm going to say x is equal to negative, b is negative 8, over 2 times a, which is 2. So this is 8 over 4, which is 2. My x coordinate of my vertex is 2. My line of symmetry is x equals 2. And now I need to find my y coordinate of my vertex. So y coordinate of my vertex, well, I'm going to plug it back into my original equation. Y is equal to 2 times x is 2 squared minus 8 times x, which is 2, plus 6. So this is y is equal to 2 times 4 minus 8 times 2 is 16 plus 6. So this is equal to 8 minus 16 plus 6. So y is equal to 8 minus 16 is negative 8 plus 6 is negative 2. So my vertex is 2, negative 2. So the vertex is 2, negative 2. And the equation of the axis of symmetry is x is equal to 2, like I said earlier. The parabola opens up if a is positive, and it opens down if a is negative. A does the same thing as A has done previously. That A doesn't change. I'm going to graph it doing the same thing in the same way. It doesn't change. At this point, how am I going to graph it? Well, remember, I'm going to go to 2, negative 2. I know my A is 2, so that 1, 3, 1, 1, 1, 3, 1, 5. Remember the way that works is I'm going to go out. Remember how this works. You go out 1, up 1, but it's 1 times A. So out 1, up 2. Out 1, up, not 3, but 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So it's going to be right here. And so then we go out 1, up 2. Out 1, up 1, 2, 3, 4, 5, 6. There would be my graph. Now there's one other thing that I could have graphed right off the base that I didn't talk about. It's my point C. It's my point C. When x is 0, my y-intercept is always whatever C is. So it's 0, C. So 0, 6 just happened to be this point that I plotted, but I can always plot my y-intercept 0, 6 straight from the equation. So before we do a lot of these graphing, let's see what we can do with quadratic equations. Remember, when I have a quadratic equation, I can always change from one form to the other, write the quadratic function in standard form, intercept form into standard form. So this is intercept form. How do I want to do this? Well, I want to FOIL this out. There's two ways I can do this multiplication. The first way is box method. Now, if your teacher taught you the box method before, I would take the first binomial and write x plus 7 along the side. The second one is x plus a negative 2. And in the box method, I just multiply corners of boxes. X times x is x squared. X times a negative 2 is negative 2x. 7 times x is 7x. 7 times negative 2 is negative 14. Now when I combine like terms, I'm going to combine diagonally. So I end up with x squared plus 7x minus 2x, so that's plus 5x minus 14. Now I'm going to put this in parentheses because my original equation had a negative in front. So my equation turns out to be y is equal to negative x squared minus 5x plus 14. That's how I can use this if I want to do the box method. Now, a lot of people have learned FOIL. So to go from intercept form to standard form, I can FOIL. First would be x squared. Outer would be negative 5x. Inner would be plus 1x. Last would be minus 5. Remember, I do have a negative 3 in front of all of this. So y is equal to negative 3 times x squared minus 4x minus 5. Distribute the negative 3 to every part of my equation. I get y is equal to negative 3x squared plus 12x plus 15. That's how I do these problems. All I'm doing is expanding to standard form, ax squared plus bx plus c. I can change anything that is an intercept form to standard form. Here's another example. If you want to go ahead and FOIL this out or use the box method, you can. I'm going to go ahead and skip letter C and go on to intercept form. Excuse me, to vertex form. What if I have vertex form? Well, remember what vertex form tells us. This is really y is equal to negative 2 times, this is x minus 4 times x minus 4 plus 3. And if worse comes to worse, I can just FOIL that. If I remember what a binomial squared is, I could just work out that function, but I can go ahead and just FOIL this. First, x squared, outer minus 4x, inner minus 4x, last minus 16, plus 16. Negative 4 times a negative 4 is 16. I still have the plus 3 on the outside on the right and the negative 2 multiplied on the left. I now need to distribute that negative 2, well, combine like terms, negative 2 times x squared minus 8x plus 16 plus 3. Distribute the negative 2, I get negative 2x squared plus 16x minus 32 plus 3. Finally, combine like terms. I get y is equal to negative 2x squared plus 16x minus 29. There is my standard form when I start with vertex form. Two more examples that we can do. I'm going to go ahead and do the one with the fraction. You can do letter B on your own to make sure that this makes sense to you. I will have the answer in class. So y is equal to 1/2 times If I remember what x plus 2 squared is, I can just write that down. Or I can say that this is x plus 2 times x plus 2 minus 3. FOIL out the middle binomials, and I get first is x squared, outer is 2x, inner is 2x, last is 4 minus 3. Remember, I always have to distribute that, well, combine like terms. X squared plus 4x plus 4 minus 3. I have to distribute that 1/2 first before I can subtract a 3 because multiplication always comes before subtraction. Y is equal to 1/2 x squared plus half of 4 is 2x. Half of 4 is 2 minus 3. Now I can combine like terms, and I get y is equal to 1/2 x squared plus 2x minus 1. That is now in standard form. So that's changing vertex form to standard form, and before then we did intercept form to standard form. What else can we do? Well, let's actually do our graphing. Let's graph y equals 2x squared minus 8x plus 6. I know that a is 2, b is negative 8, c is 6. Now before we go on, this is this problem that I already did, this quick little graph of over here. So I'm going to go ahead and I'm going to skip this example, and I'm going to start on this one, the big ugly one. Okay? A is negative 4, B is 56, C is negative 194. Now, just like I had said when I did that other one, I can start off with my y-intercept. My y-intercept is 0c, 0, negative 194. Now, that's really far down. I'm really not going to plot that for this particular problem because that's way far down, but I could if I wanted to. What do I need to do instead? Well, let's go ahead and find the x-coordinate of my vertex. I'm going to say that x is equal to negative b over 2a. This is negative 56 over 2 times negative 4, which is negative 56 over negative 8, which is positive 7. So now I know two things. I know my axis of symmetry is 1, 2, 3, 4, 5, 6, 7. And I know the x-coordinate of my vertex is 7. Plug that into my equation, and I get y equals negative 4 times 7 squared plus 56 times 7 minus 194. So this is going to be y is equal to negative 4 times 7 squared is 176. Let me double check that math. Excuse me, 196. Thought I had a mistake there. Plus 56 times 7 is 392 minus 194. If I put all of this together, now I already made another mistake. This is a negative 4, so this should be a negative 196. And I get my y to be 2. So I know that my vertex is at the coordinate 7, 2. And again, I can go ahead and use that method I did before of out one, Now this is a negative, so it's out 1, out 1, down 3, out 1, down 5. But remember, a for this one was negative 4. So when I go out 1, instead of going down 1, it's 1 times a. So it's down 1, 2, 3, 1, 2, 3, 4. Out 1, down 1, 2, 3, 4. Out 1, down 3 times 4 is 12. 1, 2, 3, 4, 5, 6, 7, 8. I'm not going to have space for 12 on here, but pretending that I did, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 8, excuse me, it should be 1 out though. 8, 9, 10, 11, 12. And so that's going to be my parabola. And again, I want to plot 5 points. When it comes to these graphs, I want to do 5 points. So let's try doing this one more time, see if we can remember our steps. First, A, when it's in standard form, I want to pull off what A is, what B is, and what C is. I do know that the coordinate 0, C is my y-intercept, so 0, 12 is a point I can plot. So that's the coordinate 0, 12. That will be on my graph. Let's find my line of symmetry. So x is equal to negative b over 2a. b is 1. A is a negative 1. So this is 1/2. My line of symmetry is at 1/2. Get a little more space. So this is x equals 1/2. Now I need to find what my y-coordinate is. So I go back to my original equation, and I say that y is equal to negative 1/2 squared plus 1/2 plus 12. So y is equal to 1/2 squared. 1/2 times 1/2 is 1/4. So this is a negative 1/4 plus 1/2 plus 12. Negative 1/4, remember 1/2 can be written as 2/4. So this is y is equal to 12 and 1/4, because 2/4 minus 1/4 is 1/4. So I'm going to have my vertex at 1/2, 12 and 1/4. Remember 1/4 is 0.25. So it's going to be a little higher. Well, let me use a different color. 1/2 and a little higher, so my graph is going to come down. Oh, come down like that. And that's what my graph is going to look like. It's kind of weird, it's kind of ugly, but that's what it's going to look like. Can I find other points? Sure. Remember, the way that this works is I can go out 1, down 1, and that's going to give me all the points I need. So I go out 1, down 1, gives me a point here. I can go out 1, down 1, 2, 3. Now all these coordinates, or a lot of these coordinates, because this starts at halves and quarters, they're not going to be perfect, beautiful points. They're going to be fractions. They're going to be decimals. It's not going to always be pretty and nice and the most beautiful thing you've ever seen. But these are doable problems. You can find the y-intercept. I can find the x-coordinate of my vertex. I can find the y-coordinate of my vertex. I can graph these points. I'm going to go ahead and stop, even though there is another example. Again, you can try that on your own and see if it makes sense. Have a nice day.